Last year, I reported 5 small vulnerabilities to the same company. Total payout? Just over $3,000. And here is the weird part. None of them were advanced hacks. No 0 days, no crazy exploits, just the 5 most common bug bounty vulnerabilities that companies miss, again and again. In this video, I will show you how often these bugs appear, the average payouts hackers are getting, how they stack up against other vulnerability types, how companies try to fix them, and why most beginners completely overlook them. If you are starting bug bounty hunting, these 5 bugs might be the fastest path to your very first payout. But before we start, one of these vulnerabilities once paid a hacker over $20,000. And most beginners never even test for it. Stay till the end, because I am also going to give you a clear, step-by-step action plan for what to do starting today. All right, let's start with number 5. Number 5, server-side request forgery, or SSRF. Now, I know what you are thinking. That sounds complicated. It is not. Let me explain it with a story. Imagine you walk up to a post office and say, "Hey, can you mail this letter for me?" And the postal worker just does it. No questions asked. Even if the address says internal server, AWS cloud credentials, confidential database. That is exactly what SSRF is. The server makes an HTTP request based on user-supplied input without checking where that request is going. Attackers redirect it to internal cloud metadata endpoints, internal APIs, or sensitive services completely hidden from the public internet. Why does this exist? Because modern apps use webhooks, URL previews, PDF generators, and import features, all of which fetch URLs. Developers often forget to validate where those URLs actually point. How common is it? SSRF is ranked as a cloud-era surge vulnerability, showing up in 5 to 10% of bug bounty reports. It was so serious that OWASP added it as its own category, number 10, for the very first time in 2021. What does it pay? Average payout on HackerOne? $3,337 per finding. Meta paid $31,500 for a single SSRF via their URL preview feature. Shopify paid $25,000 for one via webhook. You heard that right. One bug, 25 grand. Compared to alternatives like Open Redirect or XXE, SSRF is rarer, but the payouts are dramatically higher, especially in cloud environments. How do companies fix it? Allow list-only URLs, block internal IP ranges, disable unnecessary URL schemes like File and Gopher, enforce IMDS v2 on AWS, and add network segmentation so servers cannot reach what they should not. The insider tip. Most beginners only check the AWS metadata endpoint. Big mistake. Also test GCP, Azure, and Kubernetes API server endpoints. Blind SSRF misses 60% of HTTP-only checks. Use Burp Collaborator or Interact Seach for detection. Okay, number 4 is the one that made the biggest breach in banking history. Let's go. Number 4, Insecure Direct Object Reference, IDOR, also called Broken Access Control. Let me make this super simple. You log into an app. Your user ID is 1234. You look at the URL. It says /user/1234. You change it to 1235, and boom, you are looking at someone else's account. That is IDOR. The server trusts the ID you send. It never actually checks, hey, does this user have permission to see this object? It just fetches it and hands it over like a waiter who forgot to check your reservation. Speaking of waiters, I once changed my seat number at a restaurant and ended up at someone else's table. The food was great though. Do not recommend. Why does this exist? Developers handle authentication well. Who are you? But completely forget authorization. What are you allowed to do? Those are two different things. And most apps fail at the second one. How common is it? Broken access control hit #1 on the OWASP Top 10 in 2021. It is present in 94% of tested applications. HackerOne data shows it is the fastest growing report category, up 134% since 2017. What does it pay? Average payout range is $300 to $10,000. But here is the real secret. Add account takeover proof to a $500 IDOR finding, and it jumps to $5,000 to $50,000. How do companies fix it? Every database query must include an ownership check, where ID equals this and owner ID equals current user. Centralized authorization middleware, role-based access control, and automated tests that confirm cross-user access fails every time. Expert tip: do not just test GET requests. Test post, put, delete, and patch with other users' IDs. APIs are the #1 IDOR surface. Test every single object reference parameter. UUIDs do not fix IDOR. If you can see the UUID, you can use someone else's UUID. #3 is declining in frequency, but when you find one, it is almost always critical. Let's talk SQL injection. #3, SQL injection. SQLI. Here is the simplest way to understand it. You walk into a library and ask, "Do you have a book by the author? Drop all books, .. And the librarian just deletes everything. That is SQL injection. The database treats your input as a command, not as data. One parameterized query would have prevented the Heartland payment system's breach. 130 million credit card numbers stolen, $140 million in fines. 1. Query. How common is it? SQLI sits at around 9.6% incidence rate, ranked top 3 on OWASP. Hundreds of SQLI CVEs are filed every year. It is not dead. It is just hiding inside APIs, GraphQL endpoints, and ORM raw query methods. What does it pay? $500 to $25,000. Modern critical SQLI findings on major targets can fetch $15,000 to $50,000. How do companies fix it? Parameterized queries and prepared statements. Every time. Principle of least privilege on database users. Never expose database errors to users. Blind SQLI works with or without error messages. Common myth to bust. We use an ORM so we are safe. False. Raw query methods and string interpolation in ORM calls are still vulnerable. Expert tip. If the quote character errors out, do not give up. Try time-based blind, quote, and sleep 5 .. That is often where the real payloads live. #2 has the lowest frequency, but the highest possible impact. A single finding can compromise an entire server. #2, remote code execution, RCE. If IDOR is someone reading your diary, RCE is someone moving into your house, changing the locks and hosting a party. A very bad party. RCE allows an attacker to execute arbitrary code on your server without physical access. Full system compromise. Game over. Log4 shell. CVE-2021-44228. Hit every Java application on the planet simultaneously. 3 billion devices affected. Exploited within 72 hours of disclosure. CVSS score? 10 out of 10. Perfect score. In the worst possible way. Why does it exist? User-controlled data reaches an execution context, an OS shell, a template engine, a deserializer, without sanitization. The runtime interprets your input as actual executable instructions. How common is it? RCE is the rarest of the 5, but the highest severity. It consistently earns the maximum payout at every major bug bounty program. What does it pay? $5,000 to $250,000. Apple paid $100,000 for an RCE via iCloud. Intel pays up to $100,000 for firmware RCE. Facebook pays up to $250,000. How do companies fix it? Avoid OS command execution entirely. Use language-native libraries instead of shell commands. Disable dangerous deserializers. Sandbox template engines. Restrict file uploads. Patch immediately when CVEs drop. Expert tip: SSTI detection is your fast lane to RCE. Inject double curly braces, 7 times 7. If 49 appears in the response, you have template injection. That is often a direct path to OS command execution in Jinja 2, Twig, or FreeMarker. And number 1, the most reported vulnerability on HackerOne is up next, but it pays less than you think. Here is why that matters.
Number 1. Cross-site scripting. XSS.
XSS is the most reported vulnerability on HackerOne, making up 18 to 23% of all valid bug reports every single year. Here is how it works. You find a comment box. You type script tag, alert 1, close script tag. No escaping happens. Another user loads the page. Their browser executes your script. Game over. Cookies stolen, session hijacked, account taken over. The Sammy worm in 2005 infected 1 million MySpace accounts in under 20 hours using stored XSS. The creator got arrested and sentenced to 3 years of probation. That is commitment to testing. How common? 76% of web applications were vulnerable to XSS. It was number 1 in frequency, but number 3 to 4 in actual business impact. What does it pay? $150 to $3,000 for basic XSS. But chain it. XSS plus CSRF token theft leads to full account takeover, and now you are looking at $10,000 plus. How do companies fix it? Output encoding, content security policy headers, HTTP-only cookies, React JSX defaults, and DOM Purify for rich text inputs. The key lesson that changes everything. XSS is most common, but RCE is most valuable. Frequency does not equal severity. Optimize for impact, not volume. Always chain vulnerabilities. A solo XSS pays $300. Chain it with CSRF for account takeover, and it pays $10,000. All right, here is your action plan. Starting right now. Right now, install Burp Suite. Bookmark Portswigger Web Security Academy. Both are free. Today, complete the SQL Injection and cross-site scripting intro labs on Portswigger. This week, create accounts on HackerOne and BugCrowd. Read 10 disclosed reports per vulnerability type. This month, complete all OWASP Top 10 coverage on Portswigger Academy. Practice IDOR on DVWA. Here is the truth that changes your bug bounty journey forever. Authorization is harder than authentication. Most developers handle "who are you" perfectly. But what can you access? That is where apps fall apart. And that is where you find the bugs. Remember, context matters more than payload. The same XSS script fails in one context and earns $5,000 in another. If this video helped you, smash that like button. It genuinely helps the channel grow. And if you want my next video, Bug Bounty for Beginners, where I walk you through setting up your very first test environment from zero, hit subscribe right now, because that video drops soon and you do not want to miss it. I will see you in the next one. Happy hunting.